Hello, everybody. John Adams from Keysight's NSS, here to give you some information about Keysight's CloudLens platform. So this is visibility for all the clouds. During this presentation, I'm going to talk a little bit about market trends, and from there we'll go into challenges, why the cloud matters, and what is the CloudLens platform in a very light way. So the cloud has become the dominant IT model. 93% of all organizations are moving to the cloud or building clouds, whether it be on-premise or in the public sector. The cloud spending is increasing. 50% of all of the spending is on the cloud, and we're expecting that now in 2020, even with the, actually probably even more so now that we're in this corona virus situation, this pandemic. With that, we also see public clouds are becoming mainstream, and a lot, let's say over half, 2/3 are going to be moved, these applications in the world are going to be moving into this public cloud sector. With that, again, the clouds are multiplying. 84% of the organizations have a multi-cloud strategy. So this means they might have a cloud inside their own data center, but then also using services like AWS. So what is some information about the cloud? The public cloud is an infrastructure as a service, meaning you're not going to worry about the hardware, the air conditioning, and you won't have any engineers on site to run around and manage this equipment. This will be completely done by the people from AWS or Azure or Google Cloud or IBM Cloud. And you would more or less have an engineer or two that would maintain a web UI from these providers to manage this equipment that they're running for you. From there, you also have the managed private cloud, so an outsourced company that's total control. You just kind of give them requirements of what you need. From there, we move down into the private clouds. So these are clouds that reside inside of your computers or your servers. Mostly, you can think, whenever you hear the word cloud, think virtualization. So we're going to have virtualization that could be inside your PC in the form of VirtualBox or VMware, OpenStack, Microsoft Hyper-V. And these are considered on-premise with a legacy DC style system. So the public clouds are getting all the attention, but the private and hybrid cloud environment is set for growth. There's a few reasons for this. Well, the public cloud sector, I would say, is getting a lot of attention because how much more focus on what you're trying to do can you have when you don't have to worry so much about maintenance and is the air conditioning working well in my data center and things like that? How much more can you focus if you only need to build the application or build whatever it is the product that your company is doing? On the other side of this, what we do need to understand is that with the movement into 5G, we're going to see a new style of deployment using containers. And the idea of that, I'm going to have at least 3 containers that are always running an application or a virtualized network function, of which I'll have a load balancer that'll balance the traffic between these containers in the concept of if I ever lose a container, I could spin another container up and I should never lose my service. So with this type of concept, we're just looking at this is going to continue to increase, and it's going to have to be built in data centers. Once again, you can't put everything into the public clouds because you do need to manage these a little bit more, especially from the ISP side. So what are some of the drivers for visibility in the cloud? Mostly visibility is a validation process to give you the information is everything okay? So we look at network performance monitoring and we look at security. What we can say is packet data access is paramount. Gathering all the logs is paramount. Having the ability to scale with the solution as it grows, because as I was speaking about before, if I start with the 3 containers and let's say that the load increases, what will be normal in this environment is I'll spin up a 4th, the 5th, the 6th, or 7th until that load diminishes, and then I'm going to go all the way back down. And am I going to be able to keep each of these instances providing the visibility I need to understand what's happening inside my environment? Infrastructure churn is a concept of things will continue to change, and this concept, this CloudLens concept, has more or less become an agnostic, let's say, entryway into visibility, so that you're not so dependent on the platform's, let's say, APIs or the platform's ability to get the traffic out. So what are some of the changes that we did see over the last maybe 5, 10, 15 years? Before, everything was held inside the office or the data center, and very much so today, we're finding that there's a lot more activity and access going into these environments now through VPNs and remote workers, and we're probably going to see this continue to grow. So as we increase the amount of access into our environments, we are opening up attack surface, and we're going to create load. And this is going to be unusual load that, let's say, many environments were never prepared for. And now we're going to have to start making spins again to try and create a good functional network. And it's hard to see all this traffic in the clouds. What is convenient about when everything's on the wire, I can simply apply the tap and I'll get a copy of everything that comes out. On the other side of that, if I'm looking inside a private virtual cloud, I will have no access to the east and west traffic. With that, I also need to understand what's happening between my instances inside the public cloud. Even more so, the applications that run under a single or run inside of containers, these also need to have, we'll say many containers will communicate with each other just like VMs. And so we also need access into this traffic as well. Big thing here, packet data is the gold standard. Packets are everything. It is the truth, so to speak. And if you can get that data, you can quantify many, many more things, especially the more data you can get. So, I mean, a lot of these, let's say, newer analysis engines are focusing on machine learning. So machine learning is a process of taking a whole bunch of keys and making a graph and plotting how things react in certain situations. And so the idea is that if I can give the machine more information about my environment, it'll be more accurate. So you always want to have the most. So with that, 81% of these investigations tools do prefer all of the packet. In some cases, you can get away with NetFlow, and it might be advisable in some of the public cloud infrastructures when you're using distributed, say, distributed applications across many regions and data centers. So with all this in mind, and the idea of I'm going to have many, many clouds, and I'm going to have many different UIs, and I'm even going to need many different engineers just to communicate with these UIs. What is another way to go about this? And this is where the CloudLens platform comes in. It's coming in as a single pane of glass for your visibility solution for all of the clouds. So as you see here, we have a multi-cloud solution for you: private clouds, hybrid clouds, public clouds, where we can do hypervisor type tapping, or we use endpoints to create IPsec tunnels between these locations, allowing you to filter a little bit or create NetFlow data from that. On top of that, we also have the ability to bring in some of the, let's say, features from our packet brokers, such as deduplication, and going into the app stack with application identification and a real-time dashboard, or going into secure stack and getting into data masking and things such as masking just the credit card number or sensitive data inside your environment, because you can't allow, how would I say, all of your technicians to see all this sensitive data. So real quickly, of the technical point, as you can see from my host, I would have VMs inside this host that are trying to communicate with each other across that hypervisor virtual switch. What we're going to do is sit inside on that hypervisor with a service machine, and we're going to listen to the VMs you say you want to listen to. Once again, we'll filter out the traffic, and then we'll extract that traffic via GRE, VLAN, or ERSPAN. And when we start to go into the public cloud area, what we're trying to promote from our side is less of a single point of failure and allowing a multi-access type approach. The reason being is that if we just put a single packet broker on the end, let's say, of your public cloud, if this is not ready to scale or to, I want to say, have some type of disaster recovery, if this packet broker system were ever to fail or go down, then you or your system would stop. Your visibility solution would stop. So the idea that we took into it was like, well, let's put a whole bunch of endpoints in all these various systems, collect what I need from the source, send only what I need across, and each one of these systems will have its own tunnel to get there. Therefore, I don't have a single point of failure. I might have a failure of a single application, but that will not affect my entire visibility solution at large. Also, just to note, we also have the CloudLens sensor platform for use inside of the container environment. Again, this is going to be I want to say an attachment on the container where we're going to build a second or another interface, because there should already be 3 in most of your Docker Kubernetes type environments. We're going to build another interface so that we can communicate out from there GRE to extract all the data from the inside. So real quick, how does the CloudLens SaaS work? That is software as a service, where this means you're going to have a browser you're going to reach in the URL. When I install the endpoints on my, say, sources on the left and tools on the right, I'm going to send certain tags up. This is just going to be metadata to understand who am I communicating with, so I can start to differentiate between these potentially hundreds of different types of, let's say, VMs or applications I'm looking to create visibility on. So after I've sent this metadata up and I know who's who, I would then simply make connections between these 2 points and mirror all the traffic from source to the tool, either with a filter if I would like, or doing this also with NetFlow. Thank you very much for your time.